All right, so what we're going to work on today is a regression analysis and really discuss the results of a regression analysis. So we're going to do price is equal to bedrooms plus bathrooms plus square foot living plus square foot of the lot, right? And each one of these has a beta that goes along with it. Beta sub 1, and then the bedroom, plus beta sub 2, and then the bath variable, plus beta sub 3, and the square foot, and then beta sub 4, and the lot. You can name the variables whatever you want. This is the coefficient, right, for the first variable, coefficient for the second, coefficient for the third, and so on. And we're going to do a reverse stepwise regression where we're going to look at the four variables and then eliminate the ones we don't need. So the first thing I want to do is run over to data and data analysis, and I'm going to run my regression, hit OK. My Y range is my price, right? That's what I'm trying to predict. So I'm going to hit price, and I'm going to grab all of these guys, Control Shift down. That gives me the 501. And the next thing I want when I run a multiple regression, I know that I have to have these four or all the variables together that I need, and I'm going to Shift Control down. And you can tell by the input range in X that I have to go from column B to column E, which means that all of those have to be together. That's going to make a difference here in a while. I'm going to hit labels because I'm including the variable name at the very top, and then run this the way we'd run any other regression. I'm going to call this reg1 because we're going to run a couple of different ones. I'm going to delete all of this because we don't need it. And let's make this a little bit more readable. All right, so in this case, I've got okay r squared, not great. Significance of the entire thing is good. It is below alpha 0.05, so I'm good there. And then when I look at my I look at my coefficients, I have negative, positive, positive, negative. That's for you to interpret. And when I look at the p-values here, I ask whether or not they are below alpha 0.05. And this one is not. It's the intercept. I don't care about that. This one is not, this one is not. And so now we have a decision to make. And what I want to do is eliminate variables that are not significant. Not significant. Not significant. And so I'm going to take the one with the highest p-value, furthest away from significance, which is bathrooms, and I'm going to eliminate bathrooms from my results. Okay? Now, quick pause. I'm going to create another spreadsheet over here real quick that says results. And I'll tell you why we're going to do this in a second. Take my variables, Control C, and I'm going to plug in my results over here. Here's my variables. I'm going to go to regressions, and what I want you to grab here are the coefficients, not necessarily the p-value. Coefficients. Okay, and we're going to start building a table. These coefficients should be at 3 decimals. That's just kind of an industry standard. And right next to these coefficients, I'm going to write whether or not they're significant. And here's the cheat. The cheat is we're going to identify each one of these coefficients with stars depending on whether or not they're significant at a particular level. 1 star means I am significant at 0.1 alpha. This 2 stars is significant at 0.05 alpha, and 3 stars means I'm significant at 0.01 alpha. All right? So in this case, I can look at my regression results. Here's the p-values. All right, let's grab those. I'm not going to keep them. I'm going to put them over here, and I'm going to look at them. Let's get rid of that so I can see. Is this one significant? No. So I'm not going to worry about that. Is this one significant? Yes. Is it significant at alpha equals 0.10? Yes. So it gets 1 star. Is it significant at alpha equals 0.05? Yes. It gets 2 stars. Is it significant at alpha equals 0.10? Yes. It gets 3 stars. So this guy's going to get 3 stars. Or actually, you know what? This guy gets 3 little asterisks. 1, 2, 3. I can close that together, make it tight. Bathrooms, is this one significant? No. What about this guy? This one's significant at 0.10, it's significant at 0.05, it's significant at 0.01. It gets 3 stars. Again, I'm asking whether my p-value is lower than alpha, and I'm asking that 3 times. 0.01, 0.05, 0.10. Okay? My square foot lot, not significant. Okay, now which is the biggest p-value? It's bathrooms. So now I'm good on this table. I'm going to keep this for scratch. I'm going to erase all of this stuff. Don't need this. I guess I don't know how to erase that. I'll just erase it with the back of the pencil. Da, 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 da. And then I'm going to go, and now I'm done with regression number 1. I have to throw out bathrooms. So I go back to my KC data. I go back to the original. And we're going to run it all over again. This is the reverse step. When I say reverse, it means I'm going to pull a variable out. So let's do exactly that. Data, data analysis, regression. Okay, I want to remove bathrooms. Oh, I can't. It's stuck in the middle of my thing. No problem. Cancel, cancel, cancel. I'm going to take bathrooms, and I'm going to delete it altogether. I've got the other 3. Let's run it again. Data analysis, regression. And here, I no longer want to go to column E, right? It's empty now. I can just switch that to column D. Everything else remains the same. I get a new sheet. This is regression 2, right? I'm going to delete my bands because they just kind of get in the way. And our square value looks okay, not great. 500 observations. Significance is good. It's low, very small number. That's good. And then I go back and do my alpha deals again, right? Intercepts and coefficients, Control C. Go to my results. Now here I'm going to plug and play a little bit because I've got to play with this. Intercept this guy, Control X. You know what? I don't like that. Let me push it over just a little further. Okay. Intercept coefficient, Control X goes here. For the sake of presentation, I like to leave this empty column in between. Bedrooms, Control X goes to bedrooms. That one goes there. Square foot living, X goes to square foot living. That one goes there. Square foot lot, Control X goes to square foot lot. That one goes there. And you'll notice that I'm missing this one, right? Because I threw it out. It's perfectly acceptable. And then I go back to my reg 2 and I grab the p-values. Control C, Control, let's put it here, Control V, and I do the exact same thing. This one is not significant, it gets nothing. This one is significant at 0.01, it gets 3 stars, 1, 2, 3, 1, 2, 3, 1, 2, 3. This one's good, 3 stars, 1, 2, 3, 1, 2, 3, 1, 2, 3. This one, I can't read it. Not significant. Not. The intercept will always be there, you just leave it alone. And so now what I'm going to do next is I'm going to throw this one out, right? I'm going to throw that one out. But before I do that, I'm going to come and put these little stars up here that say bedrooms, significant. 1, 2, 3. That one doesn't exist. This guy, square foot living, significant. 1, 2, 3. This guy, not significant. And now I have 1, 2, 3 variables, one of which is not significant. I'm going to throw that one out. We go back and do it again. I'm going to throw out square foot lot, right? delete, data analysis, regression. This time I'm going to column C, and I end up with 2 variables, hopefully, if I did this right. This is regression 3. I'll do the same thing again. I want this guy, Control C, go to my results. Let's delete all of this. So in this example, if we look at the p-values, this one is going to be, you can tell right from the beginning, now that we've done a few, this one's going to be all 3 stars because it's 0.01, smaller than 0.01. This is going to be all 3 stars because it's smaller than 0.01. My regression is good, observations are good. R-square value has increased a little bit every time we've done this, right? So that's fantastic. I'm going to go ahead and grab these guys and go back to my results, and paste it up here, and I'm going to go ahead and grab the p-value as well. I'll go back to my results, right? And then I can just cut and paste these into my next set. Bedrooms looks good. This one, technically this one's going to go here. This one's going to go here. This one's going to go square foot living. It's going to go here. And all of this is empty. Let me clean this up just a little bit. Let me clean this up just a little bit so we're on the same page. And I know that this is going to be 3 stars. 1, 2, 3. I know it's going to be 3 stars. This is going to be 3 stars. This is going to be 3 stars, right? But obviously I don't need it because I'm going to type it in. 1, 2, 3. 1, 2, 3. Delete all of this. And you end up with an empty variable here because we threw it out. We end up with an empty variable here because we threw it out. And now I've done 3 separate models. This is model 1. This is model 2. This is model 3. And you're gonna, and your researchers are gonna turn around and ask the question, why did you throw out square foot lot? I thought square foot lot was a good explanatory variable. Well, square foot lot was not significant. Not significant. So I threw it out. And which one did I throw out first? I threw the one that was furthest away from significance in terms of largest p-value gets thrown out every time. And so this is what we call step, this is step 1. This is step 2, this is step 3, and we call it reverse stepwise because we're throwing out one variable at a time. You'll notice in this example that all of them have 3 stars, right? This means that they're all significant at alpha equals 0.10, 0.05, 0.01. If you have a p-value, for example, that is 0.034, then it's significant at 0.10, check. Significant at 0.05, check. Significant at 0.01, no. So it gets 1 star for 0.10, it would get 1 star for 0.05, there's no 3rd star, and in effect would be, let's say this is 286.7, whatever, it would get 1, 2 stars instead of 3. You then, as the reader, comes back and says, well, it wasn't significant at 0.10. Oh, it is significant. Well, my company uses data at 0.10, so they're good. My company does not use data at 0.10. We only take data at 0.01. So this is acceptable. It's got 2 stars, it's not acceptable, and so on, right? You now can determine your own alpha because you're reporting the 3 most common error rates, the 3 most common alphas with each of your variables. This is a fantastic model to present, then you make it pretty, you give it a title or whatever else. fantastic model. It's a fantastic way to show a multivariable regression and the different iterations that you took with a multivariable regression to get the results that you are presenting. In this case, I would turn around and say model 3 has 2 significant variables, and if you want to, the other thing you could do, because you have it, is you can report R square value, right? Let's do that real quick. R square value for regression number 1 is 0.47, right? I can turn around and put that here. Regression number 2, R squared value is 0.476, right? Results. I put that one here. Regression number 3, R squared value is 0.47. Results. You know, you put that in there. And then you can turn around and say, did it really change it much? And the answer is no. I think I mentioned earlier that it did affect it, but apparently not. You want to take this to 3 variables, 3 decimals, and the R square value is about the same for all of them. All right. Hopefully this represents that, you know, it should be, R square value should get better as you throw out other variables. But in this case, it's not. That's just the way, it's just the way it is.